Okay, good evening everybody. My name is Heng Hong and I'm the last speaker. And hopefully I will go through this pretty quickly, although I do have a lot to cover. Today I'm going to talk about algebraic data types in practice and how that works. I'm going to go around and explain more about algebraic data types in a second, but we're going to talk about creating applications with algebraic data types and why we should do that. So, a little bit about myself. I always wanted to talk at iOS Conf.SG because I'm Singaporean, and I haven't been able to do so because I was working in the US. So now I've recently moved back to Singapore. I love it, and so now I'm here talking at iOS Conf for my first time. I'm a software engineer at Beam, and I previously worked at Facebook for about 4 years. I worked in the iOS Messenger core infrastructure team. Basically, we do core infrastructure, app governance, I like to call it. It's pretty cool. And I'm a Swift noob, so I've only done Swift maybe for like 6 months since I left Facebook like 6 months ago. For the last 6 to 7 years, I was working on Objective-C, and to me, Swift is like that guy next door. I know what he does, kind of. I know where he works at, but I don't really know him. Yeah, okay, cool. Today's agenda, we're going to talk about hard problems in application building. What are the biggest problems we have encountered during application building, and the benefits of using algebraic data types when we are structuring our application so that we can save a lot of time and cut out a lot of a whole series of bugs. And then I'm going to do a demo, and then hopefully finish on time, and then we'll have questions. Okay. So hard problems in application building. This is going to go pretty fast. I'm going to talk pretty fast. So hard problems, what I consider them hard problems are like where people spend a lot of their time. Like when bugs tend to manifest and where people tend to not agree on a single effective solution. Right, so one of the big problems that we have is layout, right? Like there are multiple different types of layout, auto layout and declarative layout, as well as imperative layout. It's like all people still use imperative layout somehow. Basically, they spend a lot of time doing that, and there are a lot of infrastructure building around that. And then the second thing is orchestration. Orchestration is like what we call when should we do what. Like just now we talked about like animations going very slowly, sometimes it's because like there's stuff going on main thread, and there's stuff downloading at the same time, so we hide it with animations, stuff like that. That all is under orchestration, and part of building a great app is to make sure that your orchestration goes well, you're doing the right things at the right time, hiding the right things at the right time as well. It's like a stage performance kind of, and making sure that people come out at the right time. Okay, and so the third thing we'll talk about today, this is the actual thing that we're talking about today, which is state management. How do we manage state in the application? And I'm going to talk a little bit about that. Multi-threading is what makes the above 3 problems much harder than it already is, and I'm not going to talk that much about that. Okay, so state management. What's state? State is basically the application's data that basically the collective truth about what we want to show the user at that point in time, right? And that application state consists of 3 different types, roughly. I mean, I don't think that it should be boxed into these 3 types, but there has domain data, which is your domain expertise data, the application data, or like the specific to your application. And then the device state as well as application state. Application state is like where the user is in your app, right? And then device state is what, like the user's reachability status as well as their background, foreground stuff. Okay, yeah. So go. Working with state basically. As the application gets more and more complicated, there are much more states coming into play. Every day you add a new state, and basically increasing the amount of data that your application needs to know exactly what it should show the user at that point in time. So the number of permutations exponentially increases. The number of permutations of your state, the number of potential states that your app can be in, increases at an exponential rate as you introduce more and more information into the app. So what are algebraic data types? Right, algebraic data types is the usage of types or collection of types or collective types or types inside types or types with other types, and how they interact with each other, right? How do you, like when you take types and put them together side by side, what do they mean, how do you map stuff. And I think Daniel's talk on the results type one is very good explanation with great visuals that I don't have on how you can flat map and map stuff and go from type to type. And that is, in a nutshell, algebraic data types kind of builds on that, and it's more complicated than just simply just putting things together. So in Swift we have enum types, value types, and what I call immutable reference types, which is like class, but they kind of have protections, kind of like a UI image. You cannot mutate them, but they are reference types. So, and the next point is sum types versus product types. I encourage people to go and read up more about sum types versus product types because like basically if you have too many product types, it exponentially increases this much. The amount of application state permutations you have much faster. If you have sum types, which is like enums, that keeps your application state under control. All right, cool. Time to go to the demo. So basically I prepared some stuff. Hopefully everything works out fine. I need to change the display. All right, okay. Let's see. Okay, so this is our agenda for today. Wait, let me pull it up. Okay, so this is our agenda for today. We have initial commit, and then we have a bunch of stuff, right? The work things are things that I could potentially work through instead of jumping to the next one. And then at the very end, we have some bonus stuff here. That is, if I see people are not falling asleep, I would try to accomplish that as well. So let's jump right into Xcode. Okay. Xcode. Oops. Cool. Okay. So right now, this is just the very basic detail master view, which is everybody should be familiar with this. So I added one file. Oh wait, let's go to the. Yeah. Okay. Wait. Why don't I? Oh yeah. Okay. So I added this file, the data model.swift. Okay, and it's very simple. Like this app is basically about desserts, right? It's about food, and like it's about let's say I open a dessert shop and I want an app for my dessert shop. So I create a dessert shop. Okay, and then this should be pretty simple for everybody. It's not super interesting. It's a type with the dessert type has multiple desserts, right? So let's move to the next one. Okay, and so now we have. Oh, can everybody? I'll make it. Can everybody see this? Can anybody not see this? Raise their hand. Okay, good. Okay, so the next thing we want to add is just add a description string. We could do this with the custom string convertible thing, but I mean, I'm a Swift noob, so I didn't. I did it this way first. I'll refactor it later, but that's how it is right now. So this is how you handle, like, printing a string, for example, in Swift, right? And you want to handle like printing the whole description out, like saying, okay, if it's a donut, print donut. If it's a cake, print cake, right? So in the end, we return like a complete description of the thing that we have, right? So this is not super interesting as well. Let's go to the next one. And wait, what was the next one? Sorry. Oh, so adding a new case to the test. So to the dessert type. So let's say we don't have this, right? And then we build. And so when we have a new case, then we have this thing, we have this error to switch must be exhaustive, right? Which is great because we didn't have a default type. And if we had a default, then we would just like not handle that case. So one of the recommendations I have is not to have a default case. So let's click through this, and basically this thing gives you this fixed thing. So the recommendation to make a type like this, for example, if you're just typing it out just like this, you would do like this, and then the problem with here is that I don't really know what to complete here. I have to build first, right? So and I have to click on this button and then add fix, and then I'll get all my things, and then I can do this, right? So I didn't like that. So I think that makes it unnecessarily hard for people to use switches for these kind of concepts to basically handle all application states. And I mean, switches can contain also case this where this is that. So we'll reserve for this talk, we'll reserve the use of switches for that kind of manipulation. And I'm going to talk a little bit about this tool that I kind of whipped up. Basically, it's called Swift Remodel. It's like named after like the Facebook remodel for immutable objects. And basically what it does is that it generates this file for you that generates this match method. I'll just run it here. Yeah. Oops. Okay, so basically it's what it did is that it generated this file, right? And this file basically does create a match method, which basically has all the potential, the cases all handled, and it basically creates the switch statement inside it, right? Okay, so let me go to the next step. So the next step here, the next step here is that, oh, we want to add another struct. Okay, wait, let me get out of this first. Get rebase continue. Oh, no, yeah, git new. All right, cool. Oops. Okay, cool. So now we have more stuff. Okay, so just now I said, oh shit. Okay, I messed up here. I was talking about some other slide. Okay, but don't worry about that. So this next branch basically adds this donut class, this donut struct, right? Struct. And then this donut struct has the topping L. It's very easy to understand. Everybody knows donuts have toppings, and it has sprinkles, chocolate fudge, and cinnamon sugar, which is my favorite. But that doesn't matter. So if you see here, the case here doesn't handle it by default. You can build, right? Easy. Right, you can, yes, okay. So you can build without handling that donut with the switch. But if let's say we do the next one, all right, revert. Yes. Okay. So let me zoom out for a little bit. Okay. Okay. So the next, once we have the enum type match here, right? We would be able to do it like this, right? So basically you do type.match, and let me show you how that works. If I do type.match, I basically get everything, right? And so basically, therefore, I can handle all of that, and it will ask me to, and if I don't put this, and then I build, look at this. Look at this. Build operations are disabled. I need to open Xcode again. Okay, it's okay. Okay. All right. Okay. So it failed. See, what? Okay. Yeah. So it failed because it doesn't have this thing, right? It expects it, and so once you have it, it builds fine. Okay. So let's move on, right? So that is only one small thing that I didn't really like about Switch. And going forward, we're going to use this, right? We're going to use this syntax for now. But keep note that, take in mind that everything can be done with Switch. You don't need the tool at all. Okay, so let's make the data model more complicated, right? Let's see what's coming next. So at the code gen file, and now at the description string, this is not very exciting. Basically adding the description string to the donut topping type. It basically loops through, it has to handle this in optional over here, and then it says no toppings. Simple. Right, and then so next I want to add more toppings to, I want to make it have an array of toppings, right? Like, why only stay with one, right? So, go. And so, magic, yeah. And so, now we have like a topping, and then we have like for toppings and toppings, we would match, and then we'll like append everything, right? Okay, cool. And so that's kind of how I see how you would do the printing, like something like that. Okay, so let's go to the menu here. This one. Okay, so the next one is to make such that the app has some meaningful things going on. So basically, the app now is supplied with. Let's go to the master. Right. Basically, I just added some test here, and then when I hit plus, they will just pop out from here and go into the main thing. Is really not anything special, right? So basically, and you tap it in, and inside the detail is basically the same thing. Okay, so at this point, we want to. Okay, at this point, we want to add a new framework. So basically, a framework that handles the UI for us, the layout for us, the other hard problem for us. This is a framework called Theodolite. It's basically component kit for Swift. And if you've used component kit, which you probably haven't, even unless you are working on Objective-C, you would have to. You would be familiar with this. Let me just blast out that one. Okay, and then I have to do pod install. It's very quickly. Okay, and then I have to open the XC workspace. And I have to build this guy in Swift 4 because it's not really that great yet. Okay. Oh, that's my thing. What? What happened here? Xcode. Yes. Okay, so this thing just builds like normal. It should. I hope everybody is following. Okay, so let's get rid of these guys. Okay, so basically how this works is that I'm going to pass a dessert component when view did load into this component hosting view, basically the hosts component. And so here you look at it, I have on the left you see that I have two dessert component and donut component, right? And so in dessert component, basically what I've done is that I've taken the detail view, and then I've put a component hosting view on top of it, and then on top of that component hosting view I can put components, basically just like React components, right? And basically when that component renders, it will choose to either render a donut component or some other different components. As you can see, props is basically what I passed in, which is dessert here, which is quite simple to understand here. Props.match donut and donut, and I'll pass it I'll pass into the donut component the donut object itself, right? And everything else just basically renders here like this, and then I return it. And so in the donut component, as you would expect, it takes a donut, and basically if you look at it, it's still quite complicated here, but basically it's a flexbox component containing some children, and these children are in these options, which is they are displayed in rows, right? So if I have a donut, it will display all the donut toppings in a row. It's very simple. Visually, it looks very simple. I'm not very good at doing visual stuff. Let's kill this one. Is it this one? Yeah. Oh, 5.5s. Right. So donuts, no toppings, and oh man, we don't have one with toppings. It's this one, and then we can just copy here. Right. So this build. Right. Okay. Cool. So it shows, and it's supposed to be. Let's just do this. Oh, what did I do? And comma. Okay. So unfortunately, now you can still do multiple fudges, and doesn't make sense at all, right? Which is a problem that we will solve later. Right, so it will all be there. I'll refactor it a little bit, but that's basically what this. Basically, I've integrated the layout and made it into components. And basically, what's happening is that the data model is following the component hierarchy. So the hierarchy of the component tree is exactly the same as what we have in the data model here. Right, it has a branch here, and it also has a branch here, and this branch that goes down here goes all the way up and down this branch. Okay, so let's quickly move on. Let's see what's on the menu next. Okay, so the next one, I want to make it even more complicated. I want to add some secret sauce to the donut toppings. Right, let me just clear out this. Okay. And so now we have this secret ingredient stuff, right? And if you look at here, we have a new secret ingredients component. Oh, let me show you more about the secret ingredient stuff. Well, let's get rid of this. Okay. So the secret ingredient stuff is just like a mystery number and some name stuff. I just randomly came up with this, but it is part of this secret sauce thing that you can dip it in. You can add as a topping for the donut. And so if you look at the donut component, now we have this donut component. I've refactored it a bit, and so now if you see, you can see that this flexbox component contains a two children, and this children contains another flexbox component. That's where you get it properly aligned. And so in this last flex child, if you actually get to the secret sauce one, it actually returns you a secret ingredients component, which is actually a pretty simple one, which is just a flex box with children that has, we would basically align them in columns, the mystery number and as well as all the keys. So let me quickly run that. Here. Right, so something like this, right? So it would lay it out correctly. And so, so back to, okay, so the next one I want to talk about is this part, right? Yet again, this thing looks pretty disgusting. We don't want to, like, we create a child and then we go through this thing. You would encounter the same problem when you have a switch statement, right? You have a child and then you child equals this, and then at the end you say child, yeah, I got all the cases. Like Swift doesn't know that you've got all the cases here, right? So what we want to do actually is we want to return it here, right? Like child equals, like this, right? Like, but this mesh is blocking us, right? The code gen is not great enough. We need this, right? We need something like that. And so that's what this next one does. Okay, so next one does this, right? It does code gen, and magically, all these become thin, right? And then basically you can match, and then you return the child. So it looks much simpler that the children, where it goes down here, it's aligned in columns, aligned in rows, and when you run it, it basically is you can. So okay, wait, sorry. One thing that I want to emphasize, I think, that is very important amongst all this mess is that the components are not stateful at all. They are totally functional, pure, and whatever that they change, they handle everything that this donut can throw at them, basically. And they can render all the different states of this donut. But they have no logic whatsoever. You don't see even a single if-else statement inside here, right? This one's not counted because it's handling the optional, right? Yeah. Okay. So that was one thing that I wanted to focus on. And so yeah, and this would do what you think. Yeah. Okay. So the last thing, thankfully we made it to the end. We wanted to make the donut toppings a set, right? So this one I can do by myself. So I'm going to try to do it on my own. I'm just going to make it a set, right? Like this, right? And this is going to fail, right? Why? Why is this going to fail, right? Because this guy needs to be hashable, right? And so this thing needs to be hashable, basically. And will that work? I don't know. It won't, right? Because in order for this thing to work, all of these cases need to be hashable, and so does the secret ingredients thing need to be hashable as well. And so that, and now everything works. So let's test that out very quickly with this guy. Right? Let's just put it like this. Okay. Okay, let's do this. Before we do that, let's revert some of the changes on this one. Okay, let's make it back here. Let's make sure that works. This one, right? So if you see it, there's 4 strawberry fudges, which doesn't really make sense. We don't really care. We don't really want that. And so, oops. And so we make that back, and then when we run this, there. Okay, so there's only one here, which is great. Okay, so that brings me to the end of like the demo part, which is let's see, I can just do this. Okay, which basically is kind of how I would structure the application in a sense to leverage, to rely on more of the data model doing all the work on handling all the states for me, so that when I compile, I can know all the errors, fix all the errors, and be confident that it's correct, right? So when working with state, always be aware of the growth of the number of permutations, and rely on the layout infra. Like I said, I didn't really have a lot of complicated logic around, having my logic in the view itself or the component itself, right? You can think of components as views. So don't have as much as possible. Just remove a lot of logic from that layer and move it to the data model layer. And use switch statements without default cases, which also means that you should use less of if and else, because else is essentially a default for if, right? Because if and else is just 2 cases, and else handles all the rest of your default cases, and so you miss out a lot of things there. And use invariant checking. Nowadays, people use invariant checking a lot, which is great. And so in summary, so we want to use enum types, which are some types to reduce the amount of invalid states in your app. So potentially you couldn't have had a dessert that was a pudding with sprinkles on it, right? We just didn't support that. And there was no way that the app would let you build if you tried to do that. Start thinking about changes from the data model and not patching it wherever you need it to be. So let's say somebody says, oh, we want puddings with sprinkles, then you have to think about how you want to do it. I could do it in code. Basically, what happens is that you got to take that enum for donut toppings, lift it out, genericize it, and apply it also to the dessert type, right? So to make it more generic. But you have to approach it from the data model side instead of like trying to, patch it on the view side. And leverage the compiler in handling all possible states in the app. And this is what I call, I like to see how application building is like governance, right? You are essentially the government of your app and all your whole team of people working on your app. And the compiler is essentially your police force. It goes around and tries to catch people doing the wrong things. And so you want to train your police force so well that you don't have to do much and just sit back and let them do the work and catch people doing the wrong thing. So as much as possible, I aspire to do that. And yeah, so that's mostly what I have. Cool. Thank you.
Thank you so much, Heng Hong. Actually, you have one question.
Ah, nice.
I think you could help it.
Yes. Yeah. This one says, should donut be an option set? Yeah. Yeah. Great. Cool. Done. Thank you.
Short and sweet. Thank you, Heng Hong.